Welcome back. This is part 2 of our chapter 14 class problems. So we left off going into number 10 here, and I've already filled out the table as we went over in the first video, where you have the number of beds minus your x bar, then take that number, divide by the standard deviation, and you get your value there. And then what I've left open is just to go over the zx, zy again. So remember, when you are calculating your zx, zy, you find your value of z of x times by your z of y value. And when you multiply those out, you'll get your zx times zy value, which this one's 0.7083. And then you do that for every value going down the list. So this is going to be 0.23, 0.0052, 2.4, 844, 0.2298, 1.4702, 0.6492. Now remember, when we go and we're calculating our R value, we want to, our R is going to equal 1 over n minus 1 times the sum of zx, zy. So in order to get our sum of zx, zy, we add up all of these values here. When you add all these up, you should get 5.7770. Oh wow, I got really thick right there. Let's see if it continues. And then so when we put in our value here, zx, zy, the sum of zx, zy should be 5.7770. 1 over n minus 1, our n here is 7. 7 minus 1. So we're going to take not 1 point. It's 0.1667 times 5.7770. And that's going to equal 0.9630, and that is equal to your R. That is your R value. And then how do we describe this relationship? We would say that this is a strong positive association. Moving on. So on this one, same thing, we're trying to determine number of physicians full-time and number of accepted grants. So here's your table. I've already filled it out for you. I think the table itself is self-explanatory. And as we get down here, we do our R value. R is going to equal, and then we get an R value equaling negative 0.7576. And then the way we describe this relationship, remember, so now this is going to be a strong, right, because it's above 0.7, and since it's above 0.7, it's a strong. Now we're going to tell you what direction it is. It's going to be a strong negative association. Moving on to number 12. So number 12, same thing. We have a table here. I filled it out. It's the same one as the one before. Remember, just taking your x value minus your x bar, divide by the standard deviation, and then you get your z of x value multiplied by your z of y, and you'll get your values here. Once you get those, you sum them, and that's your sum. So here's our R value written out. And when we get an R value, so this R value is negative 0.1405, and this is what we call a weak negative association, right? So this is less than 0.3, our absolute value. So we say it's weak. We have a negative association there, and that's how we describe it. So moving on to number 13. Number 13 is where it actually starts getting a little bit more challenging, because they don't provide you the graph or all the other extra information you need. So for this one, we have BMI and systolic blood pressure. And what we want to do is we want to be able to determine systolic blood pressure to BMI. So systolic blood pressure is our X value and BMI is our Y value here. And the first thing the problem is asking us to do is calculate basic descriptive statistics for both variables. Well, descriptive statistics, summary statistics, Same thing, we're trying to calculate our y bar and our standard deviation of y along with our x bar and standard deviation of x, because once we have that, then we can figure out our z of y and our z of x values. So everyone knows how to do our mean. So you take the mean, you add up all the BMI from the participants, divide by the total number, and you get their mean. So for y, it's going to be 26.814. For x, it's going to be 135.57. Standard deviation, same thing we've always been doing. You have your data set, you subtract your data point from the mean, you get your deviation, you square your deviation, add up the sum of all those deviations, and you get your sum of squares divided by n minus 1 of the data set, then you take the square root, and that is your standard deviation. So for standard deviation here, you get 2.01, and standard deviation for x would be 8.162. Now that we have those, now we can go ahead and look at part B, and part B says calculate the correlation coefficient between systolic blood pressure y and BMI of x. So remember, we're trying to get our R value, which R is going to equal 1 over n minus 1 times the sum of zx zy. So we have to know what our zx zy is to get our R value. Well, in order to get that, we have to go back to our data point, and this is where you can use this chart. You can remake this chart below or carry it on through the thing, but you're taking your data point, subtracting it from your x bar, and then dividing by your standard deviation, and you're going to get a whole new value. So for your z of y values, you should get 1.4358, negative 1.1015, 1.0378, negative 0.9522, negative 0.0567, 0.3910, and negative 0.7532. And then you have a z of x value, which is going to be 0.9103, negative 0.0698, 0.7878, negative 0.8049, and then 1.1554, negative 0.4374, negative 1.54. You're going to take these values and you multiply them by each other, and then you'll get your z of x, z of y value, which will be, respectfully, these values, 0.8176, 0.7664, negative 0.0655, negative 0.1710, and 1.1599. I had these all up, and you should get a total of 3.8913, and that is your z, x, and z, y. So now going back to part B, to calculate your coefficient, take 1 over 7 minus 1 times 3.8913, and you're going to get a value of 0.6486, and that is equal your R. That is your R value. Going on, so that is our R value, just like we've been doing before. So in the next part now, we want to create a regression equation expressing the relationship between the variables. So our regression equation is y hat equals a plus bx, where b is equal to the R times the standard deviation of y over standard deviation of x, and a is equal to y bar minus b times x bar. Well, we have all these values because we have our summary statistics and we have our R value. So in order to calculate B, you take your 0.6486 and your standard deviation of y of 2.01 divided by 8.162, and you'll get a value, once you divide and multiply out, equaling 0.1597, and that's your B. A, to find the value of A, you take 26.814, which is your Y bar, minus, we have a B value now, right here, of 0.1597, and we're gonna multiply that by our X bar, which is 135.57. When you multiply it out, then subtract, you should get a value of 5.1635, and that is equal to your A. So now we're going to create a regression equation expressing the relationship. So when we express the relationship as the equation, we're going to say y hat is equal to 5.1635 plus 0.1597x. And that is our equation. And then how do you interpret this? So what we're saying is, if you have, here's your x, here's your y, here's your data scatter plots, and you have this line here, that's your best fitting line. We're saying that if I were to give you a value of x somewhere here, you will be able to determine where it lands on the line and what that y value is. You're able to predict the y value based on the x given this information. And so the way we'd write this out is, you'd say for every 1 unit change in, I'm just going to abbreviate this, systolic blood pressure, SYSBP, systolic blood pressure, there is a 0.1597 unit change in BMI, which is saying that every time our X value would increase or decrease, it would be changing the unit, and it changes that variable for your Y.